regardless of whether they make any sense in the physical world. And if you think that's odd, some numbers are so strange, they don't even seem to make sense as numbers.
Now, this is one of the most basic facts of mathematics. A positive number multiplied by another positive number is a positive number. So, for example, 1 times 1 is 1. A negative number multiplied by another negative number also gives a positive number. So, for example, minus 1 times minus 1 is plus 1.
It's not only a rule, it's a proven truth of multiplication. Whenever the signs are the same, the product is always positive.
From this, it's obvious then, if I take any number and multiply it by itself, then the answer is going to be positive. However, in the code, there's a special number which breaks this rule. When I multiply it by itself, it gives the answer minus 1.
It's impossible to imagine what this number could be, because there simply is no number that, when multiplied by itself, gives minus 1.
This isn't a number I can calculate. I can't show you this number. Nevertheless, we've given this number a name. It's called I, and it's part of a whole class of new numbers called imaginary numbers.
Calculating with imaginary numbers is the mathematical equivalent of believing in fairies. But even these strangest elements of the code turn out to have some very practical applications.
Set by Mike Lima. Ground close. Can you recall me, please? 119.7. Runway 25, clear to land. Surface winds 130, less than 5 knots.
Especially on a day like this.
A5 Foxtrot, thank you. Vacate next right and contact stand 13 short.
A5 Foxtrot, A20, both making approach, downwind left and right 25.
So where's this one coming from?
That is from Barcelona. It's an EasyJet flight. It's EZ6402. Don't know exactly how many people on board, but it seats about 190.
And here he's coming in. I can see
Yeah,
he's
he's
getting
just-
pretty close now. So.
Just less than 2 miles to go till he lands.
So what sort of information is the radar giving you about the aeroplanes?
Okay, what the first and most important thing you can get is the position of the aircraft. The yellow slash there is where the aircraft actually is.
Right.
You got the blue trail. That's the history of where the aircraft's been. So from that you get two things. You get its rough heading, which way it's going, and also its speed. The longer the trail, the faster the aircraft's going.
Radar works by sending out a pulse of radio waves and analysing the small fraction of the signal that's reflected back. Complex computation is then needed to distinguish moving objects, like planes, from the stationary background.
210, departure subject radar, NR25.
And at the heart of that analysis lies I, the number that cannot exist.
Imaginary numbers are incredibly useful for working out the complex way that radio waves interact with each other. It just seems to be the right language to describe their behaviour. I mean, you could do these calculations with ordinary numbers, but they're so cumbersome. By the time you've actually done the calculation, the plane's moved to somewhere else.
Altitude 6,000 on a squawk of 7715.
Using imaginary numbers makes the calculation so much simpler that you can track the planes in real time. In fact, without them, radar would be next to useless for air traffic control.
Guess what, 75 Mike Lima, confirm stand 10?
I mean, it's kind of amazing that this abstract idea lands planes.
It's a bit surprising. You talk about things like imaginary numbers, and this isn't imaginary, this is real.
This is very real. I'm surprised, actually, at the fact that, you know, something so abstract is being used in such a concrete way.
Campus Airlines and its entire flight crew would like to welcome everyone to Phoenix. Please remain seated with your seatbelt fastened and all the luggage stowed in the respective aircraft.
As strange as it may seem, the code provides us with an astonishingly successful description of our world. Its most ethereal numbers have starkly real applications. And its patterns can explain one of the most profound processes in nature: how living things grow.
This is a picture of something I've been fascinated by ever since I became a mathematician. It's an X-ray of a marine animal called a nautilus. And this spiral here is one of the iconic images of mathematics. Now, while I've seen pictures like this hundreds of times, I've never actually seen the animal for real.
At Brooklyn College, biologist Jennifer Basil keeps 5 of these aquatic denizens for her research into the evolution of intelligence.
So we keep the animals in these tall, dark tanks because they're naturally active at night and they like darkness. They live in deep water. And they also like to go up and down in the water column. That kind of makes them happy. So we give them the 5-star treatment here.
Right.
So this is number 5.
Oh, wow.
Yeah.
Gosh, big eyes.
Yeah, they have huge eyes. They're great for seeing in low light conditions. Here's that beautiful shell.
Yeah.
And the striping pattern helps them hide where they live.
I've never seen the animal before inside the shell. What is it?
Oh, they're actually related to octopuses, squids, and cuttlefish. It's a little bit like an octopus with a shell. And what's amazing about them is that their lineage is hundreds of millions of years old, and they really haven't changed very much in all that time. So we call them a living fossil. So it's just a really great opportunity to look at an ancient brain, ancient behavior, and they're a wonderful way to study the evolution of intelligence.
So are these guys intelligent then?
Some are smarter than others. Like, that's number 4. He outperforms everybody in all the memory tests, and he's quite active all the time. He's quite engaging. If you put your hand in the water, he comes up to you. Whereas number 3, who happens to be a teenager, is, I guess you would say, shyer. You put him in a new place and he just sort of attaches to the side and sits there.
I'm interested in the shell as a mathematician, but what does the nautilus use the shell for?
Well, I think the most obvious use is protection. They also use it for buoyancy. They only live in the front chamber, and all the other chambers are filled with gas and with some fluid. And by regulating that, they can gently and passively move up and down in the water like a submarine. And then the really cool thing they can do is they can actually survive on the oxygen in the chambers if there's a period of time where, for some reason, oxygen goes down in the ocean. So it's one of the reasons they've lived for so long, for millions of years. It's a really great adaptation. The shell is really amazing.
But perhaps even more remarkably, the rules this ancient creature uses to construct its home are written in the language of the code.
The nautilus shell really is one of the most beautiful and intricate structures in nature. Here you can see the chambers. This is the one where it lives, and these are the ones that it uses for buoyancy. Now, at first sight, this looks like a really complex shape. But if I measure the dimensions of these chambers, a clear pattern begins to emerge. Now, there doesn't seem to be any connection between these numbers, but look what happens when I take each number and divide it by the previous measurement. So if I take 3.32 and divide by 3.07, I get 1.08. Divide 3.59 by 3.32, and I get 1.08. Take 3.88 and divide by 3.59, and I get again 1.08. So every time I do this calculation, I get the same number. So although it's not clear by looking at the shell, this actually tells us the nautilus is growing at a constant rate. So every time the nautilus builds a new room, the dimensions of that room are 1.08 times the dimensions of the previous one. And it's just by following this simple mathematical rule that the Nautilus builds this elegant spiral.
And because many living things grow in a similar way, these spirals are everywhere. The rules nature uses to create its patterns are found within the code.
Gleis 2. Regio nah. Gleis 2. Sektor B. Regio nah.
Obviously quite bothered by something.
Behind the world we inhabit, there's a strange and wonderful mathematical realm.
They're actually related to octopuses, squids, and cuttlefish.
They're quite ticklish.
The numbers and connections at its heart describe the processes we see all around us.
Bear with me, all right?
Whoa.
But the code doesn't just contain the rules that govern our planet. Its numbers also describe the laws that control the entire universe. For centuries, we've gazed out into the night sky and tried to make sense of the patterns we see in the stars. Regardless of whether they make any sense in the physical world. And if you think that's odd, some numbers are so strange, they don't even seem to make sense as numbers.
Now, this is one of the most basic facts of mathematics. A positive number multiplied by another positive number is a positive number. So, for example,
Turn out to have some very practical applications.
Set by Matt Lima. Ground close. Can you recall me, please? 119.7. Runway 25, clear to land. Surface winds 130, less than 5 knots.
Especially on a day like this.
A5, Foxtrot, thank.
this isn't a number I can calculate. I can't show you this number. Nevertheless, we've given this number a name. It's called I, and it's part of a whole class of new numbers called imaginary numbers.
Calculating with imaginary numbers is the mathematical equivalent of believing in fairies. But even these strangest elements of the code is positive.
From this, it's obvious then, if I take any number and multiply it by itself, then the answer is going to be positive. However, in the code, there's a special number which breaks this rule. When I multiply it by itself, it gives the answer -1.
It's impossible to imagine what this number could be, because there simply is no number that, when multiplied by itself, gives -1.
Example, 1 times 1 is 1. A negative number multiplied by another negative number also gives a positive number. So, for example, -1 times -1 is +1.
It's not only a rule, it's a proven truth of multiplication. Whenever the signs are the same, the product is always